Welcome to Applications of Generative AI at Washington University. We're going to continue with our introduction to generative AI. I'll start by showing you some of the information actually from part one and then go right into part two, which is the primary purpose of this video. So I'm going to go ahead and open this in Colab. Most of these modules that I give you, or all of them, have an Open in Colab button at the top. You are looking at it right now in GitHub, and you can't actually run the code or change the code directly in GitHub. But if you open it in Colab, you will go into Colab like you see here. Now there's several levels that you can purchase of Colab. It's free, and everything that we're going to do in this course, absolutely, you should be able to get through with the free version, because the majority of what we're going to run, we're going to actually send off to another cloud provider, OpenAI. And in the next part, you'll see how to register for an OpenAI account and use it inside of Colab. You'll see this code at the top of every single one of these, and just like any Python code, you can actually click and run it. Things like Colab Pro Plus, which I have, I pay a monthly fee for that, and that basically gives me additional GPUs and other things that I can use, which you do not need for this course. You can certainly use just the free version. So generative AI has been around for a while, but like many things, it just now came into being in the last couple of years, mainly the text-to-text models, where you can go to something like ChatGPT, you can ask it to do your homework, whatever, which is perfectly fine for this course, and it will give you something back. Generative AI is AI that generates, obviously. So if you took my other course, some of you may even be taking that simultaneous of this, where I teach you about deep learning. A deep learning model is something that accepts some number of inputs and then outputs something. Generative AI is just running that sort of a thing in a loop where it's constantly predicting the next letter or the next token as you are getting a response to whatever it is that you put into it. We will make use of Python for this course. Python has a long root in artificial intelligence and deep learning, which generative AI is very much based on deep learning. The two major players there are TensorFlow and PyTorch. I have a completely separate class on PyTorch. Where we do need to use deep learning, we will primarily use PyTorch. Tokens and keys. So there's a number of different tokens that you will deal with in this course. These are textual sort of numbers, and it's something that identifies you. So your homework submission API key, you will get that emailed to you, and that is how you submit your assignments in this course. That's really just if you're at Washington University. If you're following this course through the internet, you won't be able to use those. But for those of you in the class, the first night of class, I will show you how to submit assignment 1. There's also a Hugging Face key. This is free. You'll sign up for that later in the course when you need it. You don't need it initially. The OpenAI key you will need immediately, because that is how we actually run the generative AIs. We'll see how to run text-to-text models locally on your computer. That can actually be done with some of the newer and more parsimonious, more smaller kind of models. 7 and 8 billion parameter models can certainly be ran on your computer. And you can run this code if you want to check your Python installation. You can install all of this onto your local computer and run it from a Mac or a Windows computer just fine. I will suggest for the course that you make use of Google Colab. And certainly the free version of Google Colab is more than sufficient. So let's look at just an overview of generative AI, and particularly the parts of generative AI that we will cover in this course. Text-to-text models are really what people often think of with this. This is where you give a text comes back. A good example of that is ChatGPT. So this course you don't really have to use ChatGPT itself for this course. It is certainly very helpful, and it will help you on the assignments for sure. So you'll probably want to take a look at ChatGPT just to use together with the course. However, what we're going to use is the underlying model that ChatGPT is built upon, which is the GPT-4o model. So we'll use GPT-4o and a variant of it called GPT-4o Mini quite a bit through this course. Now, as you watch this video in the future, this is something I will probably change. As new versions come out, it probably won't be ChatGPT 4o and 4o Mini, but you'll see the course material updated to use whatever the latest versions of those models are, because often the newer models come out, and not only are they better, they're faster. So you always want faster, often faster, and also cheaper, less expensive. So here I am making use of ChatGPT 4. I like that you can actually give it a writing style when you are having it compose text for you. So I will often tell it write in active voice, and I'll give it some other things just so that if I generate a paragraph today and I generate a paragraph a few months from now, it looks like they're at least halfway in the same writing style. Now, what underlying technology is this making use of? It's using something called a transformer. And a transformer is a type of deep neural network layer. So this is used as a part of a bigger neural network. These large language models that you use will have layers and layers and layers of these. And the more that they have, that's how you get these 400 billion parameter type models that they talk about. Or a very smaller one, like a 7 or an 8 billion parameter. It's just how many of these they have and like how many heads and other things they have configured them to have. So transformer takes its inputs and it encodes, you see this kind of sine wave there. It encodes that sine wave just to give it context so that it knows kind of where it's at in that sequence as things go into it. And it uses attention. Attention is all you need. That's a very famous paper that I believe I have linked and cited in there. But attention basically causes it to not pay as much attention to different parts of the text as others. And this basically creates sort of a inner state that it builds up. And then the decoder side, this was the encoder we were looking at, actually forms the output one character at a time. It's constantly going through this process as it generates. Another major area of this is the text to image models. These are pretty amazing. Here I am telling it a square image of a student studying generative AI. You want to tell a square or wide so that it knows the general format that you're looking for. So you can see this student here drinking coffee. Yeah, that cup of coffee is the most important thing in this study session. But secondarily, he's using a book and he is looking at all these amazing diagrams that I guess those are his notes. He's a very good note taker. I've always been impressed with people that use multiple colors and pens and stuff as part of their note taking. This also gives you a good example of something that's often discussed in AI and generative AI in particular. If you look at the person that we generated, it is a Caucasian male. I'd say maybe he's in his 20s. I don't know. I'm very bad at determining people's age just by looking at them. You didn't tell it what gender, what race, what age that you wanted. So it's going to go by what it's seen the most pictures of when you asked it to generate, and that's called bias. So it does have a bias towards how the training data, the prevalence of things in its training data, and that's a good example of it. If you generated 100 of these, you would get some variation there, certainly, for sure. But always give it very precise instructions as far as what you want. Otherwise, it'll just make something up and surprise you. Now, these images like this do not use transformers. There's multiple technologies at play here. The thing that's being used here is an autoencoder. I go a bit deeper into autoencoders in my other course, which is on deep learning. But the thing that you will always notice with an autoencoder is this hourglass sort of a look in here. You have input coming in, and it gets narrowed until it's finally just a small code that goes through the next part, and then it expands. So it's kind of an encoder-decoder sort of situation, just like you had with the transformer. Encoder would be here, decoder would be here, and it basically compresses what you ask for into a small stream of numbers, and then this part learns to decode it. And that's fundamentally how those images are actually generated. It's much more in depth than that, but if you want to read all about that, look at the academic papers on Stable Diffusion. Thank you for watching this video, and please subscribe to the channel to keep up to date with all the other things that I do with AI beyond just the course, and thank you for watching.